Hello everyone, my name is Norm Jones and I am a professor at Brigham Young University in Provo, Utah, USA. And I'm very excited to talk to you today about how to use artificial intelligence coding agents to build Tethys applications. First of all, what is agentic programming? I'm sure you've all heard of or are aware of the changes that artificial intelligence is making to programming and computer science. There are a number of ways that you can engage artificial intelligence in your coding. A very easy way is to go to your favorite AI chat, ChatGPT or DeepSeek or whatever you have available to you. Ask a question in the browser and it will give you some code, and then you copy and paste that into your code and run it. And if you get an error, you can go back and forth with the browser. Now this, compared to no AI at all, it's an incredibly powerful tool, but a much more powerful and effective approach is to use an agent. With an agent, this agent lives in your IDE or your terminal. You don't have to do much to provide the context. It can see all of your files, and that can include your code, your documentation, PDF files, anything you have in your project. And then you ask it to do something, and it interacts with all of your files, runs code, edits multiple files at the same time. And you kind of orchestrate that process and guide it along, but it is much more powerful and a much more efficient way of programming. So why does this matter? Tethys platform is very powerful and widely used, and it can be used to generate an incredible array of web applications. It has a lot of really nice advantages, including Django, scaffolding, templates, gizmos, user authentication. And it's designed to lower the bar to developing science-based web applications. However, there's still a learning curve, and there's still a fair amount of technical detail that you have to be familiar with and a lot of coding involved. And so it's easy to get lost in a lot of those details. However, if you include an AI coding agent in the process, building a Tethys application becomes very easy. It goes from hours or days down to minutes in many cases. And once you build an app, you can use the AI agent to modify it and improve it. Literally, you can go from I have an idea to running a web app in a single session. So today we're going to talk about using an AI coding agent to install your portal, build a traditional Tethys app, or build a non-Tethys web application and add it to your Tethys portal as a proxy app. And I have demonstrations we're going to use for both parts 2 and 3. First of all, what are our options available to us in terms of agents? On the left side, I've listed things that are widely available globally, and especially in the US. My favorite coding agent is called Claude Code. It's from a company called Anthropic. The models associated with that are extremely powerful, and it works really well. Another one that works really well is called Codex. It is a product of OpenAI, which is the same company that develops ChatGPT, works very similarly to Claude Code, and is also an excellent option. GitHub Copilot is developed by Microsoft and works really well with VS Code. All of these work well with VS Code. Another one that I've used a lot is called Cursor. It is a fork of VS Code, so it's an IDE, but it has a whole series of agents embedded in it, and it handles the licensing with those. You can use Claude or Codex or any of these from there, including DeepSeek. You can connect your own model to Cursor, so that's a great shot. I've also, I know that there can be some accessibility issues from China, within China, but there are a number of open source and available coding agents that you can access. And frankly, everything I described to you today, it should work about the same. The process is the same regardless of which of these agents you're using. They all, some will be better and more powerful than others, but you should be able to be quite productive with any of these. And so how does an agent work inside your editor? On the right, I have a screenshot of a session using Claude Code within VS Code. That you can see a little bit of Python there on the top. And I've launched Claude Code in the terminal window on the bottom. There's also a more polished GUI where you can run Claude Code. I kind of prefer the command line interface. And once you've launched it, you just tell it what you want it to do. So in this case, I said analyze the estimate n members function to determine where the computational bottlenecks are. Agents are really good at profiling your code, making it more efficient, cleaning up unneeded code, but also, of course, developing new code to begin with. And so you give it an instruction, a request, and then it goes through a planning phase. It reads the repo, reads all your files, figures out what it needs to do, and then it writes and modifies the code with explanations. It also will ask you for permission for various numbers of steps along the way. There are a lot of things it won't do without getting your permission first, and so a lot of times you're just giving it permission to do certain things, but also sometimes it will stop and ask you to clarify or to make a decision about how something should be implemented. And then it can actually run the code that it generates and checks the output. So it checks to see if it works and if it's met the specifications you provided. And then, of course, when it's a web application, it'll provide a URL, a local URL, which you can launch in the browser. And then if you don't like what you see, you go back and say, hey, that looks great, but I want to change something. And I'll show you an example of that as we go through our problem. And so it's actually very easy to do, and I would say it's a lot of fun. I really enjoy developing applications this way. All right, so before you get started, if you have not done so, you need to, if you want to build a Tethys app on your computer, of course, you have to first install Tethys Portal, or the Tethys Platform Software Stack, I should say, would probably be a better title here. And you can do that through the command line interface using the set of commands shown on the left. You first of all, create a Conda environment called Tethys, and then you activate it, and then you can install using pip. You can install it with either Conda or pip, the platform, but it works pretty well using pip. It's a little faster, allegedly. And then there are a couple of other commands you make, and then you start it. Now, as you go along, there might be a few issues that arise. So another way to do this, it works just as well, is you can go into Claude, launch Claude, and just say, install a Tethys portal for me. Create a Conda environment called Tethys with Python 3.12, activate it, install Tethys platform by pip, generate the portal config, configure the DB, and start the server. Now that's a pretty detailed prompt. I guarantee you it will work. But you can also just say install Tethys portal for me, or install Tethys platform. I've done that as well with just a prompt that short, and in each case it successfully installed the portal. Once it's installed, every time you bring up a new shell, you need to activate Tethys, do Conda activate Tethys, and then Tethys manage start, just like you would as you've been taught in other sessions of this workshop. All right, and then when you create a Tethys application, as you've learned in other sessions, it has a number of files, app.py, controllers.py, a series of templates, a series of static assets and public. And and then some YAML file, configuration file. When you use agentic programming, we're still using the same set of files, the same basic structure. It's the agents are smart enough to understand that. You don't even need to point it. In my experience, you don't need to point it to the Tethys documentation. You just tell it what to do and build a Tethys app, and it knows enough about Tethys that it will build all these using the correct logic. I've done it a number of times, and in each case I was able to get it working, and in most cases, in a lot of cases, it will run into some bugs and missteps along the way, but the agent is smart enough to deal with that and fix the errors and finish. So you do that. Now, once you do that, you're ready to develop your develop your Tethys app. And in this case, what you do is you give it a prompt. I generally write my prompts in a text editor or in Markdown. Either way works, and sometimes I'll have the agent help me write the prompt. And so you can give it, and it can be relatively simple, or it can be very detailed. For a Tethys app, I generally write a prompt, a few hundred words describing what I want it to do, how I want it to be laid out, how I want the user interaction to work, etc. And then you let it build it, and then you refresh and iterate. So to start off, I've got a video recorded here of myself building a Tethys app using Claude Code. This is called the Bear River Streamflow Explorer. I've asked it to, I have a prompt that I've developed here. Bear River is a basin in the Rocky Mountain region of the United States, and it has about 35 stream gauges in it. And I want a way to explore those stream gauge data. So here I'm in VS Code, and I've launched Claude in the command line, and then I've copied and pasted that prompt, and I'll give you access to the exact prompt I'm using later. And so now Claude is executing. It's checking to see if there's a Tethys Conda environment, and launching that Conda environment, and then it's scaffolding an app with the default template, and each step of the way it asks me for permission, which I can click the number 1, and this goes on for it took about 8 or 10 minutes to build this app. And so here's the result. So this is the final app. I've skipped a lot of the intermediate steps. You can select a gauge from a map, and then it shows you the hydrograph, statistics about the gauge, and you can go back and select a different gauge, and again look at the daily discharge, the average discharge, the flow duration curves. This was all in the prompt. I asked it to do monthly flow distribution statistics. You can also select gauges from this list. Again, this built the complete app, fully functional, in about 8 to 10 minutes. Now, at this point, I might think, hey, I want to show the boundary. So I'm going back to the Claude prompt, and I'm going to type, now add a map showing the outline of the Bear River Basin. Now, I could provide that map, but all I have to do is tell it to add it. It's going to go out on the internet. It's going to find an appropriate copy of that, and a few moments later, in this case, literally about 2 minutes later, if I refresh, there's the outline of the Bear River Basin. So again, at this point, you can just continue to iterate and add new features simply by going back to the agent prompt, telling it what you want it to add, and watching it do its magic. It works extremely well. And there it is in the portal. So and this, if you can go back into the IDE, you can see all of the files that it created. We have app.py, controllers.py. It created another one called usgs.py that goes out and fetches the streamflow data from the United States Geologic Survey. And so again, it works really well. Let me go to the next one. So another thing you can do is you can build an app as a non-Tethys app and add it to your portal as a proxy app. So you can use whatever React or Streamlit or Flask, whatever you'd like to build an app, and then deploy it and then link it to your portal. And so there's if you look in the Tethys documentation, there's a way to register that. You can also do it completely using the agent. So here's a Baseflow Explorer app that I created using it's just in one session. We have all of the stream gauges in the United States, and you can click on any stream gauge. So this is the working app. Again, this was developed using Claude Code, and it uses something called Streamlit. Once you select a gauge, you can select a digital baseflow separation techniques you want to highlight over on the right, and then zoom in and see how those baseflow separation techniques work on the hydrograph for the selected stream. So again, I got this going fairly quickly and deployed it on a site called onrender.com. So this is hosted now on a cloud-based repository. So I'm going to go back to Claude Code and say add this app as a proxy app to my Tethys platform. Sorry that there's some gray text obscuring that, but then I give it the URL of that app. There you can see my prompt. And then this one, actually, this one literally takes about a minute or less. So here's the entire process. It's asking me for permission. Again, all I did is say add this. I give it the URL and told it to add it to my current platform as a proxy app. It asks me for permission for a few things. Here's another one. And then there's the URL for my app, and it's done. So that took, what, 30 seconds or so? And so now I can go back to the my portal. And if I refresh it, there's my Baseflow Explorer app. And if I click on that, it's properly connected. And there we go. We'll do it again. And then that works exactly the same as before because I'm basically linked to the same app. So, in conclusion, agents are great to help you initially stand up the portal. So install in Tethys platform, install your own local portal, and then pick your agent. You can very easily build a traditional Tethys app using that agent, like we showed with the Bear River Streamflow Explorer, or you can build it as a non-Tethys web app and then integrate it as a proxy app into your Tethys portal. There's a lot more information on this URL that I have here with this QR code. Or if you email me at njones@byu.edu, I'd gladly forward you any of this information. I have a whole series of sample prompts that you might want to play with, including the Bear River Streamflow Explorer we went through today. So I'd encourage you to give this a shot. It's a fantastic way to develop a Tethys app, and you can be incredibly productive doing this. Thank you.